This video is going to demonstrate the copper lab. What you're looking at is the setup for the lab. You're going to need a glass stirring rod, a 150 milliliter beaker, a test tube rack, and a test tube holder, either a Bunsen burner with a ring stand or a hot plate with a ring stand, and another 150 milliliter beaker that's filled about halfway with distilled water. You'll need to go ahead and turn that on right away so that it's ready for reaction number 2. For each one of these chemicals, make sure that you record at least 2 things. First, the color, and in this particular series of reactions you're going to have a couple of blues, so be descriptive when you're writing the blue. Robin egg blue, sky blue, aqua blue, so forth. Secondly, you should record the state. If you can see through it, it means that it's liquid. If you know there's a chemical dissolved in the liquid, then it's aqueous. If you can not see through it, it means that there's a solid precipitate. And if you see bubbles, that means that there's a gas. And for a couple of these reactions, you may see more than one of those states present at one time. The next chemical is hydrochloric acid, HCl. When you're describing the color, notice that it has no color, so you will say colorless. Again, clear means that you can see through it or it's transparent. Colorless means no color. The third chemical is 1 molar sodium hydroxide, NaOH. For the first reaction, you're going to add 10 drops of copper 2 nitrate to a clean dry test tube, and then 20 drops of sodium hydroxide, which is also aqueous, to the test tube. To mix the chemicals, you can do one of 2 things. You can use the glass stirring rod, and if you use the glass stirring rod, be careful and stir gently because the glass against the glass could cause breakage. The second way to mix the chemicals is to form a C with your fingers and then tap the test tube between your fingers. This is what the product looks like after it's been mixed thoroughly. Notice that there is a solid because you can't see through it anymore, and also you can see some solid sticking to the side of the test tube. It's kind of a gelatinous solid. After it sits for a while, you can see that the solid settles to the bottom of the test tube. So you have that blue solid in a colorless liquid. If we take a look at the product side of the equation again, you can see we have sodium nitrate and copper 2 hydroxide, and the copper 2 hydroxide is the blue solid. The beauty of this lab is that all of the reactions occur in one test tube. So the products from this reaction will become the reactants for the next reaction. When we write the next chemical equation, however, we're only going to include the copper 2 hydroxide, and that's because the sodium nitrate is not affected by the heat in the next reaction. And chemical equations only include the chemicals or the substances that undergo chemical change. So since the sodium nitrate will not undergo a chemical reaction, we are not going to include it in the next chemical equation. So taking a look at the chemical equation for reaction number 2, you can see that we're starting with copper 2 hydroxide. You're going to heat the copper 2 hydroxide, a single reactant, and it's going to break down into copper 2 oxide and water. The copper 2 oxide will be a solid precipitate and water will be in the liquid form. This shows the copper 2 hydroxide in the hot water bath. At this point, the water should be hot, possibly starting to boil. Before you start the next reaction, the copper 2 oxide needs to cool off a bit. So take your second 150 milliliter beaker, and this time you can use tap water and fill it about halfway. Put the test tube into the cool water bath and allow it to cool for about 2 minutes. If we look at equation number 2 again, we see that the copper 2 oxide solid is the black precipitate and the other product is water. So as we begin the next reaction and write the equation, we're only going to include the copper 2 oxide because water is not reactive, so it won't undergo chemical change in the next reaction. So the next chemical equation shows the copper 2 oxide, and we're going to be adding hydrochloric acid. In reaction number 3, you're adding hydrochloric acid and you will see a dramatic color change. Make sure that you stir it carefully or tap it between your fingers to mix it, and then be patient. Sometimes it takes a moment for this reaction to completely occur. This photo shows you the difference between the copper 2 chloride in the test tube and the copper 2 nitrate that you started with. Notice that the copper 2 chloride isn't just a lighter blue, but it's a slightly different type of blue, and that's an indication that the substance in the test tube is different from the substance that you started with. The next step is to test the pH of the solution. And the purpose of testing the pH is to show you that the addition of the hydrochloric acid in the previous step has made the solution acidic. Acidic solutions contain hydrogen ions, and the hydrochloric acid, HCl, contains hydrogen ions. To perform the test, dip the glass stirring rod into the solution in the test tube, and then take the glass stirring rod to the pH paper. Never dip the pH paper into the solution because it's saturated with a chemical indicator, and that chemical can contaminate the solution in the test tube. If we look back at the equation for reaction number 3, where you added hydrochloric acid to the copper 2 oxide, you'll see that the products are copper 2 chloride and water. So as we write the equations for reactions 4 and 5, we're only going to include the copper 2 chloride because, again, water will not undergo a chemical change. The reason we're showing 2 reactions happening simultaneously is because the copper 2 chloride is going to react with the aluminum wire, And the excess hydrochloric acid from the previous addition of hydrochloric acid in reaction 3 is going to also react with the aluminum. In the case of the copper 2 chloride reacting with the aluminum, they're going to produce aluminum chloride and copper. And then in reaction number 5, the hydrochloric acid and aluminum are going to produce aluminum chloride as well and hydrogen gas. Aluminum chloride is a white solid, and of course you can't see that because it's remaining dissolved in solution. So the aluminum chloride is aqueous. As you look at the products in the test tube, the brownish red substance is often mistaken for rust. However, rust is iron 3 oxide, and we haven't introduced iron into any of the reactions in this series of reactions. So if you take a look at the products again for the copper 2 chloride plus the aluminum, one of the products is copper. The brownish red substance is copper, and what we've done then in these 5 reactions is we've taken the copper 2 ions from the copper 2 nitrate, and the electrons that were initially lost were regained during the course of the reactions to form neutral copper metal again. A final look at that last reaction between the hydrochloric acid and the aluminum shows us that the hydrogen ions in the hydrochloric acid, or HCl, are converted into hydrogen atoms. Hydrogen ions are what cause acids to be acidic, so the fact that those ions have changed into atoms means that the solution should no longer be as acidic. Low pH numbers indicate high acidity, and then lower acidity is indicated by higher numbers. So your original pH should have been fairly low, and if you retake the pH again, because the solution is no longer as acidic, you should have a higher pH number. This concludes the tutorial for the copper lab. You may watch it again if there are parts that you are still unsure about. Make sure that you have the chemical equations written down, and as you're in lab, record your observations thoroughly so that when you take the written portion of the test, you have good notes to use.